So this is the Cuttlefish Rig, if you're interested. That was in the Octane 2 animation here. I'm not going to do a tutorial per se, but I will walk through how he's set up. And there may be something interesting or inspiring in there that, or something you may want to follow up on that may be worthy of a future tutorial. But I think a lot of MODO people just like to see a complex rigged creature or character because you don't see them very often in MODO. So I'm just going to kind of go through here. In fact, let's just start from the top. If I turn on everything, and let's go to Advanced Geo here maybe, you can see the asset. So it's got a lot of stuff going on, has some really high-res texture maps on it, and it's got lots of locators going on. A lot of these are controls. Actually, almost none of these are controls. These are all, for the most part, deformers and fall-offs and bones. So I like to break things down into groups over here, as you should know by now. So I've got my geometry in this folder. There's the cuttlefish. And I've got some control curves. Let me hide these locators. Some control curves on here as well. You see some curves along the mantle frill and also on the siphon. This is how cephalopods locate, locomotion. What's the word there? Locomate. That's not a word. It's not even close to a word. So that's how they move. That's a good word. That's how they move. They bring in water through the mantle there. And it's the mantle, and it comes out the siphon, and they can actually squirt around. They have 8 arms. These are not tentacles, people. These are arms. These are tentacles. These 2 long feeding tentacles here that squid and cuttlefish have. Octopi do not have them, but squid and cuttlefish do. Nautiluses do not have them. Nautiluses, you are closer to a dinosaur than an octopus or a cuttlefish or a squid is to a nautilus. Nautili are extremely ancient creatures. They are classified as cephalopods. They're definitely mollusks, but they do not have tentacles. They have arms, but they have like up to 50 or 90. I think up to 90. Whereas squid and octopus and cuttlefish have 8. And in the case of the cuttlefish and the squid, they have tentacles as well. That's where his beak goes. There's no beak in the scene, but there is a cuttlefish-specific beak that I had made. It's just not in there right now. Unfortunately, the eyes are just painted on. Would have been nice to model fully movable eyes, but he does have some morphing ability there with the eyes. So let's just break this down real quick. So I've got a bunch of controls right here on the main locator, which is a typical place to put them in MODO. And the interesting thing about this guy is I can, if you look at these guys down here, it says mantle ripple frames per cycle, arms frames per cycle, mantle frill frames per cycle, siphon open frames per cycle. All of these here are animatable. Basically what I'm doing is I'm inputting the number of frames I want this cyclable animation to repeat. So if I sort of drag through here, you'll see the arms moving. It's kind of a heavy scene, but you'll see the arms moving like that, and the mantle rippling, and the mantle frill rippling. So you'll even see not just the frill here, but the actual mantle and head have some deformation going on as well. You can see it in this profile view. That's actually done with the texture on a texture applied to a fall off. All these things are loopable, and there's some expressions in there that let me say, oh, you know what? These tentacles, I want them to go through their cycle in 90 frames. Now let's make it 180, or let's make it 50, or let's make it whatever, so I can control the cycle length of anything, any sort of main animated component on this cuttlefish just right here in these controls. Then I've got some sort of hero controls that let me do things like crinkle the eyes, like that, or uncrinkle the eyes, as it were, or move them forward. Got a little pinching going on there. Should probably fix that. Those are just morphs. And then I've got, let me turn those off. Then we've got, so here, might as well turn this tutorial real quick. So you saw there were some issues right there with the morph. Those points are being moved, and really they shouldn't because it's just the eyes. So what you can do, if you've got badly behaving points on a morph, you can just sort of select these points. I'm just going to get out of that. And middle mouse and grab some points in here on my cuttlefish. Right around in here. Just go to shaded mode. Take a look at my morph target. Eyes crinkle. We've got a little motion in here. I don't need any motion in there. So if I right click and clear, it's only going to clear off that motion on these, that morph information, the alternate vertice position on the selected points there. So morphs fixed. Wasn't that easy? Okay, going back to setup. See, I've already thrown myself off by having an error in my rig. Bad rigging. Okay, so back to where we were. Right, so let's take a look at the assemblies here, and that'll help us. These aren't assemblies, actually. These are workspaces. So let's take a look at the workspaces. That'll help us figure out what's going on here. I've got a bins and magnets workspace and a whole bunch of tentacle assembly workspaces. 8 of them, to be in fact. I think 10 of them, because there's 8 arms, 2 tentacles, right? So obviously there's something going on here with the tentacle assemblies. And what MODO sorely lacks is the ability to right-click or push a button and organize these schematics. In fact, I could spend more time trying to organize this schematic than it would take to probably re-rig the entire animal. So, fortunately for you, I have the control tentacle in a different scene. And the cool thing about this is I did actually make an assembly, which I was able to import into my scenes and then line up in my squid and cuttlefish and octopus geometry. So this assembly right here, there's just a few things going on. Let me just kind of pull through. You see that nice wavy motion? So we've got a couple other things. We've got some control, some curl controls and curl fall off controls. Let me expand this a little bit. Get my control locator and some channels here. So while it does have a nice wave, and that it has to do with the amplitude, and let me just get these. I don't know why it's mixing them up. This is a 701 scene loaded in 801. I think I'm getting some channels out of order here. You know how that bothers me. But so there's some, the curl things, which you see rigged up right here, are just some channels on these conic cones, these little cone locators here. Those control the curl. So if I want to curl this guy, I can grab like a curl channel, and you can see it push out a little bit. You can see it curling right there. So it can curl in pretty much any direction. It could also do a sort of a curl, like a roll along the length. So if I get in closer, you can see these guys rolling, and so that's sort of a. Let me just twist it all around. See that roll there? So I can roll it that way. I could also curl in either X or Y. So here's another curl going this way. So there's lots of curl controls on tentacles, but I don't really use those much. I don't think I actually use them at all in the final piece, but they're sort of hero controls, right? But the interesting stuff is the amplitude, the oscillator nodes used for the actual tentacle motion. So I double click on this, you'll see there's some multipliers there. I'm just going to bring out one of these guys. So here is, it would be easy if I right mouse dragged all these, and I think I can right click and hide nodes. Can I hide the nodes? Can I remove the nodes? So it's basically hiding them. Right click. MODO has this bad policy of losing your selection when you right click. So remove nodes. Okay, remove these nodes. And now you've spent all your time watching me remove nodes, which is not learning a lot. So, okay, so what we have here is the skeleton spine. Here's the bone. Okay, let's look at it in the hierarchy. There's a couple things going on here. We've got a root locator here, this little circle. Then I've got a curl locator, which I kind of explained as the parent child of that, which lets me twist this guy and curl it and twist it. And then I've got the spine, which is going to be rotating around and doing the actual deformation. The skeleton spine is part of attached to a weight map for deforming. And it works the same as everything else, just kind of like a locator weight. This is essentially the channel, the effector, right, which plugs into an influence, and the influence has some points, which it gets from a weight map. And that's how, of course, the skeleton. There's no weight map in the scene because there's no geometry, but once I bind it to a geometry, it gets the influence and the points that way. At the bottom, I've got a tip locator. And the reason I have these guys, and let me activate my transform tool. When I bring this assembly into a scene, into the cuttlefish scene or the squid or the octopus scene, I can just use these tip locators in setup mode. If I would go to setup mode, I could use my tip locators to place my tentacles. So the tentacles, the actual model, they're not in a perfectly straight line, so I just gotta do it this way. So I'd go down here, and I'd go to the next tip locator, and I'd move it, and that's how I would get the tentacle lined up for binding. But what we have here is a channel oscillator. We click both of these guys, and we've got essentially some multipliers here. So I've got a multiplier right here, and that's going into the amplitude. And then I've got phase and an offset going into these controls here, offset and phase. The frequency is just a straight line. Whoops, I just disconnected it. Yikes. Frequency is just a straight line connection, okay? So, and that's not something you want to animate, but that's essentially the frequency. Eventually this will be hooked up, all 10 of these in another scene, the 8 arms, 2 tentacles, will have the frequencies hooked up to another control, which will use an expression in the frame rate of the scene to let me go in there and say I want this, basically set the frequency as a number of frames. So I could say I want the frequency, I want this entire thing to oscillate once in 90 frames or 45 frames or 2,000 frames or whatever. But that's not in this assembly, that's in the master scene. So you don't have those controls in this assembly because this is just a smaller component, sort of one step down on the rigging hierarchy, so to speak. But so that's how it works. Let me step back out, and what's kind of cool is, of course I moved my tip, I should put that guy back. Can always, let's go to setup. Let me just kind of reset this transform here. Whoops, not the root, the tip. Actually, I'll just reset the Y, remove setup value, back to 0, get out of setup. Okay, so we've got some Y motion there. I can look at my control tentacle here, and I could, let's turn off the Y, and let's turn up the X. So up the amplitude on X, and we can make sure the frequency and the phase are 1. And now looking from a side view, if we look at the X, it's kind of waving up and down. So we can wave up and down on X, or if we go back up to the top, if I were to turn this back to Y, turn off the X amplitude, now it's going back and forth on Y. And of course you can combine the two to get sort of a circular motion. So if I go to Y and say -2 amplitude and a sort of -1 phase, now I've got X and Y going on the oscillator. Basically the Y is just, if you look at amplitude X here, same thing, right? So I'm just going the same bone. Actually, this is the wrong way to do this. What I should do is, no, actually I picked the right bone. That's amazing. So it goes to the rotation Y and X of this particular bone right here, are being driven by oscillators. When they're both going at once and in opposite directions, you get a sort of a circular motion. So this rig is the first thing I created in this project. I knew I was going to have to animate tentacles. I knew I'd have to be able to control it. I knew I'd have to be able to set a frequency in it as a frame, not just a number, a time, a sort of frame, because the Unity guys are going to say, well, it has to, do like one complete cycle in 90 frames, otherwise I can't do my job. So I'm kidding, I'm just making fun of Unity guys. So all these controls are in there. So that's the tentacle. We go back up to the cuttlefish. All those tentacles there's 8 of those, actually 10 of those, right? 8 arms, 2 tentacles. Should have called it arm assembly, not tentacle assembly, because these are arms. Anyway, so the ripples are kind of cool. If I look at those, let me turn on these little deform locators here. Maybe I can hide a few of these guys, hide these fall-offs. And so looking at the ripples going on, how does that work? Well, those are magnet effectors, basically. Magnet influences, magnet deformers, I guess is a deformer is a combination, right, of an effector, an influence, and some points. Well, so we'll call these magnet deformers, and they are riding along these locators. They're attached to these locators, which are riding along these curves, right? And again, I need to be able to control the time. Each of these locators goes from 0 to 100% along this curve, and so that's done with a time cycler node and some expressions, and that's wrapped up into the larger interface of this rig. If I go to the master locator here and look at the user channels, we'll have a mantle ripple frames per cycle, and I can adjust that in here. I think I've somehow I somehow moved everything forward a lot. Let me turn everything back. Got too much going on. Okay, some sort of reasonable rate All right, very good. So these guys are going down, and they're deforming the cuttlefish here via a weight map. So if I go to, let's go to shaded mode and take a look at a list and look at the weight maps, and up here you have all these skeleton weight maps. At the bottom of my list here, I've got the mantle. Actually, that's the mantle bend weight map, but the mantle frill, you see the weight map there along the edge of it. That's what these guys are affecting, right? So they're rolling along here and affecting that. Of course, though, my curves need to be rigged as well and follow along with any animation on the mantle. For instance, the mantle, I go to my master locator here, the mantle can bend. So mantle, bend, somewhere around here. Mantle bend, that sounds promising. So, whoops, go to my channel haul tool. So when the mantle bends, that bend deformer, which I'll turn on so we can all see it. This is why you name everything. This is why I'm such a pain in the ass about naming everything. There's the mantle bend effector right there. You see this yellow guy sticking out. That has to bend to these curves as well as the geometry of the mantle, which you can also see the weight map that it's affecting. I've got another one of those guys on the tentacles there. So again, MODO's order of operations come into play. So I turn this guy off. Actually, I'll keep him on. I'm going to go up to the deformers here. The skeleton deforms first. So if I turn off all these bends and magnets and morphs, if I want to, the tentacles are still going to be deformed. So you see the tentacles deforming there. And those deform first. And then when then the bend comes into play higher up in this order of operations cycle here. So by the time it does all these arm, not tentacle, the bones and the arms are doing all their deformations, and then you've got some morphs on that, and then of course you've got all these bends and magnets and things like that, and fall offs on top of that. So bottom to top, that's the order it fires in. And the reason I did that is I wanted if I go into setup mode here and I turn on let's turn on some more locators here. These bone locators, I wanted these guys, this is how they're set up, I want them to do all their deformation there. And really this is the only way it would work. And then once these tentacles are nice and wavy and everything, then the bend kicks in and it bends them down. So you'll see, go to the side here, go to the side and turn up my bend a little bit. So mantle bend it, not the mantle, the tentacle bend. Bend those guys some more. You see they're bent down like that, and they're all animating. They're rippling and animating. Maybe where's my tentacle bend? Am I gonna bend? I have that on. Oh, I turned it off. So they're all going to animate, and you see that the skeleton is still sticking straight out, but they've already done their work. They've already done the waving around. After these guys get done waving around, then they get bent down into this position. So I'm doing what's called a hard cut. I just got that scene got so messed up because I was turning on deformers on and off to show you how they worked, but that channel had already been animated, so I was auto-keying the deformers working and not working, so kind of blew a hole in this whole demonstration. So I just reloaded the scene, hard cut. Anybody who's confused or frightened, this is back to normal because I just stopped recording and loaded the scene again and am now recording. All right, that is fascinating. Let's look at the siphon. Siphon is actually kind of cool. Let me hide some stuff here so it's a little more visible. We don't need to see those. We don't need to see bend. We do want to see the siphon bend. We don't need to see magnets on the frill, but we do want to see siphon magnets. Frill, we don't need those locators, but I do want to look at the siphon curve. Okay, so let's just look at the siphon here. Remember, this is how they locomate, not a word. It's a magnet deformer traveling down a curve, and I think I've got a little bit of a morph going on there too, maybe. No, I don't think there is a morph, actually. I think it's just a magnet locator, deformer attached to a locator going down this curve. Oh, there's a bend on here as well, so I can grab this guy and siphon bend. I can bend the siphon so it can go different directions. But again, this whole animation, this whole cycle of this guy going down the curve and this thing, if you look at the actual, there's the weight map on it that the magnet deformer is affecting. The magnet deformer starts small and gets big. You'll see it starts small when it's deep inside and then gets bigger as it heads towards the edge, and then it sucks back down as it's getting ready to leave. I'm going to make a fresh workspace so we can take a look at it. Go here. I'm just going to drag this dude in here. I'm going to drag this dude in here and take a look at how this is working. So we've got the magnet deformer, and the range has a MODO multiplier on here, and the multiplier has a time cycler, and also has a locator here. So what's going on is the time cycler has a completion node that is hooked up to an expression, which is hooked up to a frames per second cycle, and what's the second one here? Oh, a time node. So here's how this is kind of working. Just this guy right here. Let's take a look. So I have to be able to tell this guy to go, after this whole animation where it starts here, travels to the end, also starts small, gets big, gets small again. All these things have to be cyclable. It's a cycle, and I have to be able to say I want the cycle to happen in 45 frames or 90 frames or 100 frames. So I've got to do a couple of things there. One, I've got to capture all the animation in the time cycler node. So this time cycler node here actually contains animation for the up and down sort of expansion and contraction of this magnet. So if you look at it, again, there's big, the orange thing getting small, and small coming down, gets big again. So that whole animation is inside this time cycler node here, and input value. So if I bring up my graph here, there it is. This is the animation. I'm just animating this channel called input value. It's basically just a placeholder channel you put whatever keys you want in there, and then you output that value into a multiplier here because I want to be able to adjust it. So basically I have another control on my master locator if I want to increase, multiply this animation size by some other number to make it bigger or smaller, which I never really did, but I put a control in there for it. And that feeds it into the range of the magnet, which the range, of course, is the radius of this little circle here. So the completion channel drives this input value. So this input value is just sitting there, and the completion channel, when that goes from 0 to 100, it plays this entire input value and spits it out of the output value, which then goes into this multiply node and then into the range. So it seems a little weird, but you think about this node right here as a package. It does two things. It holds a value, an animated value, and that's the input value right here. This input value is an animated value, but it doesn't just spit that out from 0 to 90. It only spits out what this completion channel does. When the completion is 0, it gives me the input value right here. And then if you animate that completion from 0 to 100, it just outputs all these values along the range here. Now I made it here, this cycle is 90 frames, but the completion channel may be animated from 0 to 110 frames, in which case this whole animation gets compressed down to 10 frames, or it may go from 0 to 100 over 1,000 frames, in which case this animation will be spit out over 1,000 frames, so it's stretched out essentially. That output value is spitting out this input value, determined by the value determined by the completion percentage. So animate the completion, and you spit out this input value out of the output value, which then I can multiply if I want it bigger, make that bigger or smaller, and then feed it into the range of our magnet effector. Hope that makes sense. But the completion, I don't just give it a number. I actually have a little expression in here, and I'm going to forget how I did this now that I'm looking at it. But it's essentially, I've got time in B, so there's B, time, and I'm dividing that by A. A is the siphon open frames per cycle. So if I say 90, I want this thing to cycle in 90 frames, well, it divides that number 90 by the current frame. So if it's at frame 90, that gives me 1, which is 100%, which feeds into the completion as 100%. So 90 frames divided by the time, the time divided by the completion. So if I'm at time 90, and my channel here that I want to say I want the entire thing to be done in 90 frames, so 90 divided by 90 equals 1, so that feeds that into completion. 1 is 100%. Whereas if time is at 45, then my expression is basically doing 45 divided by 90, which is 0.5, so my completion is 50%. So at frame 45, this animation is at 50%, which is right here, frame 45. So that's how it works. That's how you can basically say, I want this entire animation, and by animation I mean the input value here, this animation. I want this entire animation to happen in this many frames right here on my user controls. In fact, I have 90 frames. If I turn that to 180, it's taking that 180 and putting in input A, and it's taking the current time, which is 45, and putting that in input B. And here's my expression, right? Which is 45 divided by 180. And the answer is 0.25, right? I think I'm doing that in my head correctly. And so it's bringing completion to 0.25. So now the completion is spitting out 0.25, which is a quarter of this 90, which is around here, 22. Is putting out this value right here at that frame. So that's how that works. I should do a better tutorial on that. But essentially, there's a lot of these time cycler nodes and expression nodes throughout this, every single one of these channels. That is on my master locator, that is mantle ripple frames per cycle, arms frames per cycle, mantle frill frames per cycle, siphon open frames per cycle. All these numbers I input here go through some sort of similar expression and into a time cycle or completion cycle. So it allows me to set the number of frames per cycle at a very high level of all the animated arms and the siphon and the mantle ripples, all at a very top level, and it all filters down through those expression nodes and time cycler nodes and gives me this animation at however many frames I want. And it's all in sync, and it's perfect. Worked out just fine. Any sort of hero animation I want to do on top of that, which is I can move the head around. Here's the head. Hey, how you doing? I can do some other stuff as well over here with I could bring up the something interesting here. Mantle frill wave height. So here's the mantle frill. I can bring that wave height up, which is basically just expanding the radius of those magnet effectors going down there, and I've lost it. And so I bring that up, you'll see these guys going up. But of course, it doesn't look very good that high up, so I can bring it back down. Anyway, that's essentially how this guy works. Bunch of controls that are running through time cycler and expression nodes, and then some additional hero controls where it doesn't make sense to cycle them. For instance, I may just, if I know my entire animation cycle is going to be 180 frames, I may throw in a few random eye crinkles and stuff like that. A few tentacle bends and siphon bends in there. And that's essentially what you're seeing happen on that animation. I actually might have that in After Effects right now. So this animation right here, all these arms are just cycling, and the ripples are cycling, and the other stuff's cycling. The siphon is cycling in here. But the bending of the mantle and the tentacles, the eye crinkling, I just sort of hero animated those guys on. So that's it. That's how it was done. And, I was going to go back and say, oh, here, want to see something cool? Let me load up a scene. This may or may not work. Let's try this one. Take a look. Okay. Loading. Loading. This is coming off a network, running and being mastered by an Apple X serve. Remember those? The 1U Apple servers? Those things were pretty cool back in the day, and mine is still running. In fact, I don't think it's been turned off in probably 6 years. So I'd say those are pretty good machines, but they don't make as much as, probably phone cases. So not that interesting for Apple to keep making those. All right, here, watch this. This is cool. I'm going to drag through this. We have a cuttlefish. In fact, let me turn off sub Ds, make this happen a little bit faster. This is a cuttlefish. If I drag the timeline, this animated cuttlefish is going to turn into wait for it, a giant Pacific octopus. Let me just go through halfway through this morph. In particular, pay attention to these polygons here. You don't know why I had Andy Brown make this for me. Look at that. He's a genius. He hid all that detail underneath the mantle. So the idea was for this whole exhibit is there's a big joystick there, and little kids can come up and morph the cuttlefish to an octopus, to a Humboldt squid, to a nautilus, back to a cuttlefish, back to a Humboldt, any of these things can morph into anything else. They have the exact same topology. This octopus here has the exact same topology as the cuttlefish. Amazing. And it has the exact same topology as this Humboldt squid that is coming up, that Humboldt squid right here, which is a very different animal, exact same topology as the other two guys. Again, all this detail, you can see the mantle detail right here of the cuttlefish. Those frills are kind of hidden right there on this guy. The only guy we kind of had to mess around with is the Nautilus, of course, because we couldn't do his whole shell. So he turns into just this part of him is morphable. Then these other guys just kind of come out in animation. These are separate objects, so you can see it. Let me just kind of go slow here. I'll do a little animation of this. See how it tucks in like that? Then he comes back to the squid. That may not have looked very good from your point of view. Let's see here. I could do that again. So squid turning to Nautilus. There we go. If I just go back here, it is a cuttlefish. So what's cool about this is each one of these animals is very different, and each one has a rig every bit as complicated as the cuttlefish rig I just showed you. I wanted to animate each animal differently, but it was critical that they had the exact same topology, the exact same number of points, and the exact same order, because what I did when I got the animation I liked with each specific animal specific rig is I exported an MDD, point cache. And all this animation is right here, is an MDD of there's one guy somewhere. Where is he? Probably right here, starting animal. And he's got 4 different MDD deformers. And all they do is cross-dissolve each other. They just cross-dissolve their opacity, just like video clips. And so as I drag the cuttlefish MDD, it's just the MDD of the baked vertex animation of the cuttlefish is now going to be blended with the vertex animation of the octopus. So it never stops animating. This octopus is doing its whole arm wavy siphon sucking thing the entire time, and it seamlessly morphs into an arm wavy siphon sucking frill rippling cuttlefish, just like that. And that would have been impossible to do if I tried to put all these things into one animal on one rig. But instead I've got 4 different animals, 4 different rigs, but the exact same topology. All the animations, once they were approved, were baked into MDDs and then just blended together. So it's not even really morphing. It's just an MDD blending into another MDD. And it essentially appears to be a morph, but it's full-on animated animals doing that. And it actually does it in real time in Unity, which is pretty cool. There's an MDD reader in Unity, and this actually runs real time in Unity, which begs the question, why is MODO's MDD so freaking slow? Because it's nowhere near real time in MODO. It's like freaking slow, man. Come on, MODO. Anyway, cool, huh? That's it.